Draw an angle bigger than 180 degrees? Probably not. They do exist. We're going to draw angles on the XY axis in what's called standard position. When you're drawing on the XY axis, the X axis is the initial side of an angle. And then the angle rotates to what's called a terminal side. So we always start by drawing here on the X axis, and this is the initial side. And then angles rotate. I'm just going to do a common rotation. I'm going to rotate to about right here in quadrant 3. That would be where the angle terminates. You want the angle to be the stuff down here, don't you? Isn't that what you want? The stuff at the bottom to be the angle? But it's not. It's the stuff on the outside of the top. That's the measure of the angle. I rotated through 2 full quadrants. How many degrees did I cover when I rotated through 2 full quadrants? 180, because each quadrant's 90. And then I rotated about halfway through quadrant 3. 45. So I rotated 180 and 45. How many degrees of rotation did I just show? 225. This is a 225 degree positive angle. I know it's new drawing something bigger than 180. Oh yeah, it would be. That's the next thing you notice. Angles have both positive and negative rotation. So the next thing your notes talks about the difference between a positive and negative angle. A positive angle rotates counterclockwise. That means left, by the way, if you have no idea what it means. If you don't know what clockwise means, watch the second hand on that clock, right? Clockwise rotates which direction? Right. Counterclockwise rotates left. A negative angle, if a positive angle rotates counterclockwise, how's a negative angle rotate clockwise? So what's up next in your notes is most likely drawing some angles. Some of them positive, some of them negative. Some of them bigger than anything you've ever drawn in your life. So, first one's a negative angle, which I know you've never drawn. It's not a big deal. How's it going to rotate? Clockwise. I'm going to use clockwise. I'm not going to use righty-lefty. It rotates clockwise. Where's it going to start? Positive x-axis. All angles have an initial side on the positive x-axis, and then they rotate. Is it going to rotate through quadrant 4 or through part of quadrant 4? A little over half, right? 50 is a little more than half. It's going to rotate roughly, it's going to be hard to do by hand, roughly 50 degrees through quadrant 4. And that's what a negative 50 degree angle looks like. They're not hard to do. Next up is 240. What you got there? Counterclockwise is positive. How many full quadrants are you going to rotate through? 2. Because if you do 2 quadrants, you cover how many degrees? 180. Start here, rotate 1, 2. There's 180 degrees accounted for. What's left? 60 degrees of rotation, which is how much of a quadrant? Exactly how much? 2/3. Kind of hard to do with drawing, but it's exactly 2/3 of a quadrant. It does say show the rotation. That's why I'm putting arrows, by the way. You start here, you stop there. Initial and terminal. You don't have to write the I in the 2. But that's what a 240 degree angle looks like. What's a 600 degree angle look like? Well, of course you can. It rotates full circle 1 time. And then some more.
You just overlap it, or
Well, you don't overlap your rotation. You can show the spiral. You rotate a full circle, that's where you'd be, isn't it?
You go back.
You take away your 360 you drew.
Go across 360.
Take away your 360, how much is left? 240.
You go across 360.
No. Got ahead of yourself. The reason I wasn't answering you. Take away 360, there's 240. You're not going to go through 3 full quadrants. You can go through 2, and then another what? Another 60. So a 600-degree angle looks exactly like a 240-degree angle, because it starts here and it stops there. They look the same when you think about where they start and where they stop, don't they? That's a concept called coterminality. Coterminal. You'll see that down here. Can you find another equivalent coterminal? Coterminal means same terminal side. So the question that's being asked here is, can you find another equivalent coterminal angle for examples A, B, and C? Example A was a negative 50-degree angle. And that was a negative rotation. What if you rotated positively to get here? How many degrees would it have been? A positive rotation. 310. Finish the circle. Circle's 360, you know 50. 310 left. 310 degrees looks exactly the same as a negative 50-degree rotation. Based on what you've done already on drawing, what's something that's coterminal with 240? 600. Examples B and C were the same, weren't they? Ignoring the spiral.
Could it also be like negative 120?
Of course it could be. You already caught on. Good. Why did you get the negative 120?
Clockwise.
You're adding or subtracting the measure of a circle, aren't you? That's what's happening. To find a coterminal angle, you add or subtract how many degrees? 360. If you do negative 50 plus 360, you got 310. If you do 240 plus 360, 600. You do 240 minus 360, you get negative 120. Plus or minus 360 degrees for coterminality.
Wait, so what would be the other one?
They all have an infinite number of answers. Because what can you keep adding or subtracting? 360. You get the exact same location. So, what's something that's coterminal with 600 we've already done? 240. What's something new that we haven't mentioned? That was subtracting 360, wasn't it? What else can you do? 960. Those angles will lie in the same exact spot. We'll talk more about coterminality another day. Today was just its introduction. There's more to it. That's coterminal angles, and that's drawing simple angles. So what's up next in your notes is probably getting to be the discussion of radians. It is. You have the verbal definition of a radian, which I personally think is god-awful to a teenager. It says a radian is the measure of a central angle that creates an arc length equal to the radius of the given circle. Interesting. So if you have two radii that intersect at the center of a circle, they would be by definition congruent. And they form a central angle whose measure is 1 radian. Radian abbreviated RAD, rad. And it turns out if that central angle is 1 radian, and my diagram doesn't do it this justice, but that arc is the same length as the radii of the circle. That's what a radian is. That's its verbal definition. The verbal definition won't do you a whole lot of good. The mathematical definition does, and also the mathematical approximation in degrees will do you some good. So what's in this little box is more important than what was typed for you. On any standardized test, you need to know that a radian is 180 degrees over pi. Use the pi symbol, not pi. And if you go to your TI-84 and you type 180 over pi, it'll tell you 57.3. Some of you guys might remember that from your benchmark. Almost every single year there's some easy question on the EOC. Which of the following might be the graph of 3 radians? Which of the following might be the graph of 1 radian? And all you have to know is that a radian is roughly how many degrees? 57.3. That's all you have to know. Easiest type of question they can ask about this stuff. And they do ask it. That's why I'm saying it's worth memorizing. That's why it's on your flunk quiz. Maybe you'll memorize it. We also use something called a pi radian, because pi radians are cleaner numbers. So 1 radian, which I just defined mathematically to you, was 180 over pi. Mathematical definition, 180 degrees divided by pi. And if you cross multiply it, you'll get something what we call a pi rad. So if you say 1 radian over 1 is equal to 180 over pi, and if you do some cross multiplication here, what's that 1 times that pi? What's 1 times pi? A pi radian is equal to 1 times 180 degrees, which is, so pi is worth 180 degrees. A pi radian is the measure of half a circle. How about 2 pi radians? 360. 2 pi is the measure of a full circle. And it's just different forms of measurement. It's like the difference between centimeters and inches. It's just something a little bit different. Okay? Don't think it's anything new, just how we measure angles. We use pi radians at upper level math because it makes the math simpler than using degrees. It does make the math simpler. You'll get a slight taste of that in algebra too. All right, convert the following angles measured into degrees into the equivalent radian. In this room, there's at least 4 of you that know this on your form quizzes. How do you convert from a degree into a radian? Formula's on the form quizzes. Pi over 180, that's right. Multiply by pi, and it's technically a radian. You'll hardly ever see me mention that part. Over 180 degrees. The reason you do it is because what you'll see when you actually set it up. When you actually set it up, if you like to write on paper, what do the degree symbols do to each other? They cancel. It's no longer a degree. It's the only unit left, which is a radian. No, you gotta do the multiplication. You can do it in your head, you can use a calculator. It's not gonna kill me. I wish you wouldn't use a calculator, but some of you have to. You know, what I would do is I would think 30 over 180. What's it reduced to? 6. So this would be pi over 6. I know not everybody can do that. If you're one of those kids that makes no sense to, you just need to legit follow the formula. But in a calculator, you don't use the pi key. Because the pi's are going to do, sorry, you don't use the pi key in the calculator. What was that, 30 degrees? You're supposed to multiply by pi over 180, do 1 over 180. No, when you go back to a piece of paper, you have to put the pi back in. Angela would have taught you this last year. I know she would. She would have taught you how to write exact form with pi. And she would have shown you how to use a calculator. You just don't put it in a calculator. You don't do something silly like write 0.17 either. Can your calculator convert fractions? You can. Hit math, enter. 1/6. 1/6 of what? Pi. The pi was not thrown in the calculator. And nobody, and I mean nobody, writes 1/6 pi. Nobody writes it like that. What's 1 times pi? This is how it's written. I've never seen a single person ever write a fraction like that with pi. Leave the pi up top. All right. You guys do C. And if you can't do it in your head, push the buttons the way I just showed you. All you do is multiply by 1 over 180. Nothing more. That's from somewhere else. Yeah, so explain all I did the first time. I'm sure you got the answer. Those of you who weren't pushing buttons the first time and don't remember what I did. One more time. 600 parentheses 1 over 180. Enter. Don't write 3.333. Math answer frac. 10 thirds. 10 thirds of what? Pi. What's up, Pam?
So, it wouldn't be powerful.
For this one? No, this is 10 over 3 pi. 10 pi over 3. Which one's he doing?
Wait,
Oh, did you do B? B is pi over 4. B is pi over 4, but I circled C, kids. I know what I said. I said y'all do C. But if you got pi over 4, at least you know you're doing that right. Why don't you guys do D? We get a nice whole negative number. No, just type it in. Don't think it.
no. I got it.
If it's a negative degree, it's going to be a negative radian. What was she? Negative 3 pi rads. I am very guilty of not writing the rad part. Yes. Are you supposed to write feet squared for area? Yes. Are you supposed to write feet for feet when you're measuring? Yes. Just depends on the question. You need to understand that's a radian. It's not a degree.
Where's Brady?
There's a mode, you'll never use it.
Why?
Because you won't.
Can you, or you don't teach it?
I will probably, with y'all, since you're new to this concept, have you always convert to degrees.
So like,
But if you figure
C
out
would be
how to
like
use it.
10 pi rad over.
Be very cautious about using radians.
You have to put 10 pi rad over.
Hmm?
You have to put 10 pi rad over.
10 pi over 3 is actually fine. Like I said, I'm guilty of not putting units in. All right, here's the other way around. Converting radians into degrees. If you convert a degree into a radian by doing, if you do a degree into a radian by pi over 180, what's the opposite? 180 over pi. The way you remember which one to do, when I had to do it when I was young, I always thought about what I needed to cancel. I need the pi to disappear, don't I? So where's the pi got to be? In the bottom. Hopefully that makes sense. That's why you do it, because it causes the cancellation. And I'm old school. I'm not going to push those buttons. 180 over 6, what is it? 180 over 6, what is it? That's negative 5 times 30. Negative 150 degrees. A lot of these things can be done quicker in your head than they can be by pushing buttons. But if you're not that kid, you can just type it in as it's written. You guys should know how to use your fraction key by now. Math, num, n over d. If I can press buttons. That was a negative 5 pi over a 6. You can actually put the pi symbols in here. Because what's going to happen automatically in the calculator? They're going to cancel. You can use parentheses if you want. You can use a multiplier symbol if you want. Doesn't matter. Math, num, n over d. And it was 180 over pi. You don't have to worry about the pi symbol when you're going from a radian into a degree. -1 Think however you want to do it, okay? You want to do it in your head, do it in your head. I encourage you to, but I also want you to get things right. Do C, not B. Don't do D because I'm going to change it. No, it's wrong. I'm going to change it. -4 pi radians. 4 times 180, isn't it? 720. Pi's, a lot of times what I'll do too is pi's with 180. So if I see a pi, what do I make it? 180. Just depends on how strong my brain is on any given day. Because I have most of these memorized way on out. I've done this forever. Should have got 135 degrees on the thing. No? Yes. I'm going to change D. I'll make D with no pi. Just -2.5 radians. How are you going to convert that into degrees? You're going to use the exact same formula. It's still a radian. This is a formula for radians. It's not a formula for pi radians. It's a formula for radians. You're still going to multiply by 180 over pi. You're not going to get a very pretty answer. It's just not going to happen. The radian unit itself is ugly. The pi radian is pretty. Pi radian generates whole numbers usually. But the radians themselves are ugly numbers. This is going to be a fugly looking decimal. You don't have to use the fraction key if you don't want to. You know how to use your calculator. -143.24 degrees. But notice that those things with pi's, and they usually turn out to be nice little numbers. If you don't have a pi, what do you usually get? If you got a pi, don't you get nice little numbers? If you don't have a pi, what do you get? Decimals. The pi radians are pretty. Radians themselves are just ugly.
You know, just leave it over the top.
That would still be ugly.
Okay.
I've never in my life seen anybody leave it like that. Ever. I'm not saying it can't be done. I'm saying I've never seen it. All right, here's the ones you need to memorize, and these are on your form quiz. Now, the way you can do these quickly without memorization is to know what pi is worth. What is pi worth? As a measure of an angle, not 3.14. As an angle, pi is worth 180 degrees. So anytime you see pi as an angle, you can just rewrite it as 180. What's 180 over 6? 30. How about 180 over 4? That's right, Tanner. About 180 over 3. 60. That's how you do these things real quick. How about 180 over 2? Now remember, you ain't using a calculator on a form quiz. 90. You're not using a calculator on a form quiz. Mr. Simmons let y'all do that one day. I don't know why, but it ain't happening again. Now, when you see 2 pi over 3, no, you think of 2 times pi over 3. You see it? 2 pi over 3, is it not 2 times pi over 3? And what's pi over 3 worth? It's written on the board. 60. What's twice 60? 120, Parker. How can you view 3 pi over 4?
45 times 2.
Yeah, you can view it as 3 pi's over 4. And the pi over 4 is 45. That's 3 45s. Last I checked, that's 135 degrees. You've already done that in your notes.
You can still do like 2 times from there.
Okay.
Like 360.
Okay. One of those will be quicker. It'll be me. 5 pi over 6. How many 30s? 5 of them. 5 30s makes 150. Pi is worth what? And that twice that 180 would be 360. So you want to go toe to toe with me on mathematical computation, huh, Parker?
No.
I wouldn't do it. I'm only about 50% right now. You catch me on a good day, I'm impressive. All right, draw the following radian measures. That one was on your benchmark. 2 rads. For drawing purposes, I wouldn't use a formula. I'd use the rough approximation of a radian. 57.3 degrees. Memorize it. It's in your notes. You took it. Swear you did.
No, I would radian.
A pi radian is. I don't know what you wrote. 1 radian is 57.3 degrees roughly.
Oh,
So if I was asked to draw, I wouldn't use that formula, push buttons. I wouldn't. If I was asked to draw 2 radians, I would literally figure out what twice of 57.3 is. Yes, please quit pushing buttons. You can do that in your head. You ought to know enough to draw a 114.6 degree angle. Is it going to rotate through quadrant 1? Yeah. And a little bit of quadrant 2, right? It looks something like that. That's roughly what 2 radians looks like. The only other one I want to do on this page is C. Now notice, I took a radian and I converted it into degrees, didn't I? What are you going to have to do on C? What are you going to convert it into? Degrees. You're going to have to do that. Figure out what 7 pi over 4 is as a degree. If you want to use your little formula, use your little formula. But figure out what that is in degrees. Because that's what you know how to draw. You're on day 1 of radians. Nobody expects you to look at a pi rad and know what it looks like. Nobody. $3.15 is right all day long. At least 3 ways to get that. I would have done 745s when I was your age. How many full quadrants does that get to rotate through? That'll get you to 180. 3 will get you to 270. What's left? $45 is left. Half a quadrant is left. That is what a 7 pi over 4 angle looks like. Oh God, we're going on time. We got 2 slides to talk about here. This one is a formula slide. I don't think you remember these formulas from geometry. They're dealing with sectors, slices of pizza over there. When you did geometry, you found arc length, which is how long that piece is, by comparing the measure of the arc in degrees to the measure of a circle, 360, as its length compares to circumference. Anybody remember doing that? Oh, I got some nods. Cool. In algebra, you get to use an easier formula. We call arc length S. I don't know why, but it's the radius times theta. Notice what it says highlighted for you. What is theta going to be? Radius. Use another proportion for area down there. In algebra 2, you get this little formula. 1/2 r squared theta. You get easier formulas with radians. You do. You get nice, easier formulas. That's what radians do. They make things like proportions disappear. So there's your 2 little formulas. And all we got is one example. It's about a sprinkler. Most of you guys have seen a sprinkler. This sprinkler shoots water 24 foot rotates through an angle of 30 degrees, and the edge of the sprinkler would be curved, wouldn't it? That's what you call a sector. It looks like a slice of pizza, she's a sector. Is that a part of the circle? Yes. If it was a circle, what would its radius be? 24. Okay. If you want to find the area the yard is watering, you get to use 1/2 r squared theta. But what's the deal about theta? Radian. Is 30 degrees a radian? You wrote down what 30 degrees was as pi rad. What's 30 degrees is pi rad? 5/6. It's in your notes where it is. Memorize it. Otherwise, you have to use your formula conversion. Plug in and you're done. 1/2, 24 squared, 5/6. Now, if you take a test in here, I'll have the answer in exact form. Sorry, that's in the way I can't drag it. If you want to answer in exact form, what do you not put in the calculator? Pi. All right. So I do 0.5, 24 squared times 1/6. 48 pi square feet. Yeah, you too. I did one of these in your homework for arc length, so I guess you have to look at that video. Sorry we didn't finish. You guys had questions? But there's more instruction in your homework video. That's what it's for.